All right, so now, you all understood. All I wanted you to do on the first four was just to put the x in place of it, right? And just put it in your calculator. Just so that you get used to looking at what an exponent is, finding what the difference is, even if you plugged in a radical or you plugged in a pi sign, or you didn't have to change your mode on that because you weren't dealing with any angles. So you didn't even have to change your mode on that. These guys, yes. My other period was like, they look just like what we did yesterday. Yes, and that was my intent. So that you see they graph the same way, the same core graphs, even though their base changes, and even though this one should probably be a little steeper than the 3, I want you to see that they have the same shape, they pass through the same intercept point, they have the same domain and range, same asymptote, same everything going on. Is that what you saw? Yeah. Okay, good. So that's what I was looking for here. These are reflections. Remember, if the negative is next to the x, you work your finger from positive x to negative x. Where's your reflection? Y-axis. If the negative is over here, it's not next to the x, it's next to the y. You work your finger from positive to negative. Where's your reflection? X-axis. Easiest way to remember your reflections. Okay? And these guys, I wasn't very clear in the directions either, but just so that I said, just get a good feel for what they look like. They were already graphed for you. So you can kind of look at this one and say, I have a horizontal shift to the right too. Remember, I said I kind of use this point to help me because it's really the only markable point that we put on your sketch. If I move this to the right too, this should be at 2, 1. And that looks like it's at 2, 1, right? Now, my y-intercept changes for this. That was my y-intercept for my core. To find my new y-intercept, I use my rule. X is 0. I come to my equation. I plug in the 0. So it's 0 minus 2, it's negative 2. Negative 2 says flip it over and square it. So my new y-intercept is here. Look how close it is down there. See it? You can almost see the 1/4 on the screen. It's a little bit easier than looking through your calc when they make it a larger picture. This again shows you the reflection. Here's your original one. Here's your reflection. Okay. This one showed you the vertical shift down. So if I started with this point 0, 1, and I went down 4 minus 4, this point is 0, negative 3. And look, it is. Right? If my asymptote was y equals 0, and I subtracted 4, then my asymptote is y equals negative 4. And that looks like it is, right? Not down to the negative 5. So it does make sense, right? By looking at these graphs. Sometimes when you put them in your calculator and your screen is on a standard screen, you don't see the exactness of it as when they look at it and blow it up a little bit for you. Your calculators also have a bad way when you do these. They kind of go like this. They make it look like it stops right there, or they do this. And they make it look like, whoop, that's the last point we're going to get. You know, you don't see that it's an asymptote. You always look at your table. The last two, probably again I wasn't too clear, or maybe you were talking, but you had to go find some of the transformations. They said, here's my core, my parent, and I'm going horizontally 5 to the right. So I can start with the 0.01, add my 5. I can talk about my intercept change, my new intercept, what it would be, increasing function like we talked about in the classwork one where we described it all, domain, range, find your domain, find your range. If your asymptote changed, your asymptote doesn't change on a horizontal shift. This one, in a vertical shift, my asymptote will change. Okay. bottom one, if you notice it goes like order of operations. If you put a value in for x, it's going to force it to do this piece first. So it's going to shift it to the right first, then it's going to shift it down 3. And if you find your new y-intercept, that's what I was kind of looking for. That you just kind of like, you describe these, look at your domains, look at your ranges, look at your asymptote, right? Pretty basic on the graph. Any questions on this part? No? Okay. We're going to take a look at today base E. Someone came up with this little formula.
I don't know why.
Someone that had nothing to do with their spare time, I guess.
No one.
And they realized your number system is a base 10 number system. They realized as they increased the value of x and it got closer and closer to the highest number possible, that eventually y would kind of reach a point where it pretty much kind of stays right at this number. If I keep increasing x to a zillion trillion, it will still return a y value of this number. So they said this much must be your natural base for an exponent. So they call this natural base E over here. We call this your natural base E. And I don't need you to know this formula. I don't even need you to know this. But if you kind of remember that it's close to like 2.7, because what it means is this. Here's your graph of y equals 2 to the x. Here's your graph of y equals 3 to the x. A little bit less, a little closer. So where does 2.8 fall? 2.7? Kind of right in between there, right? So if I was to graph this, I would find, come in between here, closer to the 3, this would be my natural base right here. Because this is my 2.7 to the x. If you graphed in your calculator, e to the x, and you graphed 2.7 to the x, they would look like the same graph. It still works like a natural base. It is our natural base, but it works like the base of any other exponential curve. Now, when you find your e to the x, over on the left side of your calculator is your log, and then your ln. Right above your ln is e to the x. So when you hit that, it puts the e, and then it positions your cursor right up here, so you can put in x or 2x or x minus 5 or whatever you need to put in here. Now, I just want to caution you a little bit about your calculators. When you, in your calculator, put 2 to the x minus 5, if you're using one of the newer calculators and it raises it up here, you're fine. If you're using the 83s, 2 raised to the x minus 5, parentheses, very good. So the same thing's going to happen with your e. It's going to raise it, or it's going to give you the, on the old ones, it's going to go like this. So if it's raised and you need to put in x minus 5, you put it in. If it's here, you have to put in, don't forget the parentheses for that. Anything you raise to a power. Okay? So your natural log, all I need for you to know is that your base E log is like the base of 2.7. It falls somewhere between the 2 and the 3. And it behaves the same way. The point in the middle, the intercept, is the 0, 1. I have an increasing function. If I put a negative up here by this x over here, when I raise to the e, I get a reflection. If I put the negative in front of the e, I get a reflection over the x-axis. It is the same as any other base that we use. Okay? Make sense? That's all I need you to know about base E. When we get to the log part of it. It's when we have to use the inverse of that, the ln versus the log. Anything with a base e will use an ln. Anything without can use either the log or the ln. And when you get to college classes, you very rarely see the word log in your book. Everything's pretty much ln. Because ln can be either one. It's kind of like the blood donor thing. O can give to anybody. ln can give to anybody. Now, if you put this in your calculator, it behaves just like anything else. This is causing a little bit of a dilation. So here's your base, e to the x. This, instead of being at the 0, 1, is now going to be at the 0, 2. Because it's going to dilate it a little bit. It changes the distance from 0. But the rest of it will look like the same base. Anything with a negative will cause it to be a decreasing function. So you're going to see that. As long as you know where to find it in your calculator, I'm good with that. Now, today also we're going to talk about compounded interest. Okay? Now, before we go into this should look a little familiar, this formula right down here. This basically is what we use. This one up here is shortened because this one used compounded annually. Compound is your n, and you might want to add this. This is how many times you compound. How many times you calculate interest per year? If they compound monthly, then an n would be a 12 months to a year. They compound annually, one time a year. They compound quarterly, 4 times a year. Okay? So the reason this is shortened is because when n is 1, you don't need this fraction here, and you don't need the extra 1 there. But this only works if you're compounding annually. Otherwise, we're going to clearly use this one. So we're going to kind of stick with that one anyway. Now, before we even get to this, all I want you to do is put your pencils down, and I just want you to listen for a few minutes. Because kids your age are at a disadvantage, and it happened to you last year. We hit you with this real fast, and you're like, compound? Accrue? What does this mean to me? It was a nightmare because you obviously don't invest money. You're juniors and seniors in high school, and last year half of you were sophomores and juniors, right? So let's just talk about investing money for a minute and where this interest comes from. So say over the Christmas or Hanukkah, Kwanzaa break, whatever you celebrated, your grandparents are giving you a gift. So your grandma gives you $100. That's a nice grandma. Okay. Now, your grandpa makes you a deal. Your grandpa says, well, grandma gave you the $100, and you know it's from both of us, but I always give you a little bit more, grandpa says. So grandpa says, I will give you interest on this. So at the end of the year, I'm going to give you 10% interest on your money. Now, if you take your money out, you're going to not earn as much interest, right? If you leave your money in there and you let everything keep accruing, that's our accrue. We invest our principal, $100. We have a rate that we invest at, and the interest we gain goes back in. So now at the end of the year, I left my money in. I go to Grandpa. I said, I got my $100 in there. You said 10%. So Grandpa says, all right, let's multiply this by 10%. You made $10. So what did you do to that $10? You're very smart. You added it. You didn't go spend it on foolish things. You added it to your $100 because you know next year now your grandpa has to give you 10% of 110, right? Which is a little bit more. Yeah, well, it keeps accruing, right? Now, okay, now, shh. This is what I want you to see. I had to physically add my $100 back in, right? So we have a little formula, and what this 1 plus does, it says 1 plus my rate. This gives me 1.10. Now, when I multiply my $100 times this, I get 110. Because that 1 says, when I do this, so let's break it down. What's 100 times 1?
10.
Wow. What's 100 times 0.10? 10. And when I add them together, there's my 110.
I'd rather not answer that.
So, what this 1 plus does is it rolls your money back in. Obviously, the bank doesn't want to have to put a formula in, stop, have someone add it to your money, go back, put another formula in, stop, add it to your money. It wants one formula that keeps rolling your money back in. So whenever we do an increase, something that has gained, we do the 1 plus. That's why we do that. It's your principal, 1 plus your money. Now, if at the end of the year, you took your $100 and your grandpa says, I'm going to take 10% of your money.
Awesome.
Yeah, and said, I'm just going to take 10% because I know if I give it to you, you're going to spend it. So he's going to take 10% of your money. So again, we multiplied it. And then what did we do with this 10? We subtracted it. And we got $90 left. So, now watch, guys. Watch. If we're taking this formula and we're decreasing your money, we're going to do 1 minus the rate. You're going to see this in your formulas. An increase is 1 plus, a decrease is 1 minus. If we take 1 and we minus your rate of 0.10, we are left with 90% of your money. That's what's left after we take away 10%. So if we just multiplied your 100 by 0.90, don't we get $90? God bless you. Don't we get $90? Instead of taking the 100, taking 10%, then subtracting it, this 0.90 is what you have left. Make sense? Okay. We increased it. We took your 10. We rolled it back in. We take your 10. We take it away. And we're left with 90% of what you put in. Because this time, well, Grandpa said, I'm going to take 10% of your money this time. I'm just going to take 10% this year. So he's taken off 10%. So what's he going to leave you with? 90% of your money. 90% times 100 is 90. Now, okay. Charlene's a Kohl's employee. Kohl's is my favorite place. Charlene was explaining to me, someone showed her how to calculate percentages.
Wow.
This is the way I show all my kids how to calculate. You're in a store, and when I teach 8th grade, I start my percentages with, you go to the store, you see a jacket for $50. It's 30% off. So they charge you $40. You say, wow, that's really good. I saved $10 on this jacket. You go home, you say to your mother, it was, what did I say, 30%? 30% off, and I saved $10. Your mother says, you saved more than $10 for 30% off. And you figured out, you took your little ratio and you figured everything out and say, darn, I did save more. So the salesperson made quite a little commission on your article. So, when you go, you have to know what you're looking for. If you remember it this way, 30%, and on a 10%, you move your decimal one place. So my jacket's $50. If I multiply it by 10%, I get $5. 10%. $5. For every 10%, I save $5. So if I have 30%, which is 3 10%, how much should I have saved? 15. But they said 10, and it looked good to me. Yes.
Now, when you go to an action store, you always have change. So how do you do it with change?
Okay, I'll explain that change in a second. But now, my point is this. You save 15. So in your mind now, you have to say 50 minus 15. What if you're bad at subtracting? You forgot to carry the 1. You forgot to borrow the 1. You can't take out your cell phone. You're not getting any reception. It's not working. It's broken. Okay. You don't want to look like a nerd when you're standing there looking at your calculator, right? So now, if you save 30% of your item, how much of it are you paying for? 70%. Isn't everything worth 100%, just like we calculated here? So if I only need to pay 70% of my item, I figure out my 10% and I multiply it by 7. How much do I need to pay? $35. So that's a good way to do your percent. And it also helps you here. If I increase, yeah, I got more. If I decrease, take out my 10%, how much of it do I retain? 90% of it. I'm paying my 90%. My 90%, if something's worth 100%, you took 10 points, or you took 10 of it away, I still get 90 back, right? So that's what's left in my account, my 90%. Now, in terms of pennies and stuff, you can always like round it off, as long as you know approximately where it is. Like if something's $55, $5.50 you save. But if you're multiplying it by 7, maybe you want to round it between 50 and 60. Round it to 50, figure it out, say $35. Round it to 60, $42. Now you know you're paying between 35 and 42. Rather than, sweat out the little pieces. As long as you have an estimate, you're smack in the middle of 35 and 42. You can figure it out a little bit easier. Like, play with your numbers. But more importantly, you have to make sense out of your numbers. You have to know where they're coming from. Okay? So now, we take a look at this, and we're going to take a look at an example. And we're going to use this formula.
Do we have to memorize that one?
Yeah.
It's on the regions, right, for trade?
It is, but it's not on your formula sheet. Most of the time, the Regents gives this to you. I don't see it till the minute you take it. Yeah. I don't see it. Now, let's break this apart. I'm giving $1,000. Is this my principal or my accrued?
That's your principal.
That's your principal. So let's pull it off and make our information box.
I'm going to have to spend a lot of time on this. So much.
I'm invested at 8%.
So
You have to take your rate and flip it to a decimal. So what would you do, Ricky? 0.08. You're going to move it 2 places to the left. What if it's this? 8.75%. How do I move that decimal? 0.0875. Okay, what if it's 0.2%? 0.002.
I mean 2, what am I saying?
0.002. You're always moving it 2 places to the left to go from a percent to a decimal. So now, we come here and say after 1 year.
That's the time.
That's the time. Very good. Time is 1 year. Now, here's your N's. Your N is annually, your N is quarterly, your N is monthly, weekly, daily, and then we have a special one, continuously. Anybody remember what the formula is for continuously? Look at your sheet real fast. P-E-R-T, PERT. Good. PERT. PERT is all by itself. Now, so, the only thing that's going to change, we're going to plug all our information in. We have 1,000. 1 plus my 0.08 over n times 1. The only thing that's going to change for each one of these is your n. Right? Because we want to see how much. Now, this formula has like an algorithm thing in there. It calculates how it would figure out your interest over and over. So let's start with your annual. If we do annual, what is n equal to? 1. Good. So we put it in. This is your shortened formula. Remember this one had the short one? Because of this. And 1 times 1. So I really don't need to have that fraction in there. I can do this. See how it's rolling it in? All I want is after 1 year. So I calculate this. And because this is money, when you give the answer, just put a dollar sign. You don't have to hold the dollar sign all the way through. It's annoying. Put the dollar sign in and round to 2 positions like you would money. Okay? So annually, if I compounded this using this formula, I would now have $1,080 at the end of my year. Don't get excited because there is no one in this world that will give you 8% on your money. No one. You might get 0.08% now. Isn't that terrible? That's terrible. That's what I'm saying. You might not even notice it anymore.
It used to be high, right?
It used to be nice. It used to be like 3%, 5%. Those were real interest rates back in the day. They were nice.
It used to be high.
Yeah. I mean, granted, we had less to put in. You know, everything's relative, but the interest rates were nice. Okay, so quarterly. What's N if I'm quarterly? 4. Think 4. How many quarters in a dollar? 4. So I'm changing where my N is. 1 plus, and I'm raising it to 4 times 1. Because 1 is my time, remember? 1 is my year. So all I need to do is put this in my calculator. The thing you don't want to do, you don't want to recalculate this, then add it, then do it. Put the whole thing in your calculator at once. Your rounding should only happen at the end.
Shouldn't it be smaller?
No, it should be larger because you're compounding more times a year. So you're going to see the difference is not the greatest, but it still is a little bit larger. So a little bit more money when they compound quarterly. Now, for monthly, how many months in a year? 12. So we're going to do N is equal to 12. So we're going to do this whole thing, and we're going to put a 12 in here. You got to put it in 2 places. Follow your formula. You put this in your calculator. What? Because we're on the monthly.
12 months in a year.
We did quarterly. We're doing each one. We're compounding. We said, Aquila, we said everything stayed the same except how often we compound our money. So we're seeing what difference does that make. And if you notice, from annual to quarterly to monthly, we've increased a little bit. A little bit. Now, if you're investing a lot of money, it makes more of a difference. But, you know, investing a little money. Now, weekly, how many weeks are there? 52. Good. You guys are smarter than my last group. They couldn't figure out how many weeks in a year. So, weekly, we get, now remember this is money, so go 2 decimal places.
That's what we get a week?
No, that's what you get by the end of your year. Your time is still 1 year. We didn't change your time.
So
Your time
people
is still
do
1
this
year.
all the time to see how they get the most money.
Well, yeah, you would want to invest the best way possible for you. Like, you're investing 1,000. What if you were investing 1,000,000?
Yeah.
You know, that would make a nice little difference. So how about daily? Daily,
365 point something.
we'll just leave it 365.
is exact.
Wow, that's pretty good.
That's why we have to leave you.
Wow, that was very good. Okay, so we get a little bit more. And then the last one is continuously. Now, continuously has its own formula. PERT. We call it PERT. So we still invest 1,000. We use the E for the natural base. Our rate is 0.08, and our time is 1. It's a little bit of a different setup than the rest. So we plug that into your calculator, and we get 1,083.29. So you can kind of see that that's a little bit better than my daily. The algorithms must be close because they're very, very close.
So in real life situation, does continuously, is that like the best?
Continuously is your best. That, you know, they're constantly compounding your interest. And not the same like every year, not the same as a yearly type thing, but It is a good way to end it. Now, I'm going to hand you out your homework, and I just have to make some changes to this. You got some?
I didn't.
I'll let you do my homework tonight.
Yeah, do it.
You want to ask one, I know.
Nathan has
I have.
Nathan has one. Edwin, do you have one?
I do not.
Ooh, I got $50 in my pocket. It's on.
So, guys, could you just give me a minute?
Yeah, Mom.
Okay. The first three, thank you. The first three look like the ones from last night, where you have to take it and plug it in. So, hang on for a second here. Can you read everything that it says?
Yeah.
Okay, so you're going to plug in, I apologize it's so late, but you're going to just plug the x value in. Like the first one, you're going to do e to the x, and you're going to plug in 9.2. You're going to do e to the 9.2.
And the E's on a calculator.
E is on a calculator. On the left-hand side, where it's ln, it's on the top. So you have to do second ln. It'll give you this. If you have the updated, it'll bring your cursor up here. If it's not, it'll go like this.
What is 55?
Okay, I'll explain 55. 55, I just want you to graph it. So for number 55, just say graph. Graph it, and then maybe just tell me like domain and range.
Wait, so Miss, what were you changing on the top? You just writing on the top.
I didn't, in case you couldn't read it. I just said take the x value and just plug it in for x.
Oh.
Yes.
For number 30, is it negative x?
It's e to the negative x.
Oh.
And the x is equal to negative 3/4. If you didn't, if you saw it as positive x, that's fine. As long as you're doing the substitution is what I'm concerned. Like that has double negatives in it, so that's why they put that there.
In the back, you just.
Okay, now the back, here's how the chart works. Let me explain how this chart works. Okay, you have a chart, and it says N and A. So this is 1, 2, 4, 12, 365, and continuously, right? This is your N. Your information is not there. Your P is 2,500. Your rate is there. It's like 57. Your rate is 2%. Your time is 10. But what they want you to do is to go through this chart and calculate just like we did before, changing your N, just like we did.
How did you find the P?
The P, I gave you the P. I was missing on the page. I penciled it in, and it didn't come out. Okay, one more thing, guys. On the bottom, the invested P is 12,000 for the last two. For 61 and 63.
Good afternoon. Today is an A day.